Okay, so what I've got up in here on the computer is the engineering mechanics class. So you guys can figure out what's the assignment in for mechanics. This next one, as you know, the trusses we broke trusses here in Enid last Friday. We broke trusses on Wednesday for everybody else. And the truss report for Tonkawa is due 5 o'clock on Wednesday. It's due today, 5 o'clock. Did I say 5 o'clock today? I think so. I think it's at 5 o'clock today for the truss report. So that way we can keep it straight. And remember, this truss report is only for the design of the truss and for when it broke primarily, because we are going to do more on the truss report later. But that's where this one is, and it's one report per team. The next project is the bridge project. You're assigned teams of 3, and the teams are assigned down here. So down here in Enid, it's Jonathan, Armando, and Randy. And then over in Tonkawa, it's Ali, Yasmin, and Mahdi for one team. And I've got Zach, Lansden, and Ben, you're one team. And then Jordan and Michael, you're the other team. So you've got the team. And so what we're going to do is you have to construct a bridge using the following specifications. Okay? Constructing a bridge using the following specifications. The base of the bridge is 46 centimeters. It must span 40 centimeters. So I'm going to set the desk distance apart 40 centimeters. Okay? It is a bridge. So you think about a model car going across the bridge. So it's kind of a double truss. So it's got to have a ramp. It's got to have something. It's going to have some kind of a floor to it. It must be 15 centimeters wide, and it must span the 40 centimeters. The goal is to support as much weight as possible. So that is the goal. And the weight is going to be, the testing is going to be by setting weights on top of the bridge. These are the materials that you are allowed. You are allowed 16 pieces of standard copy paper. That's it. 16 pieces of standard copy paper. And you can have 1 meter of masking tape. The masking tape cannot be structural, but that's how you can make sure your pieces stay in place. So you can have 1 piece of masking tape, and it's 16 pieces of copy paper. And we will, as with the truss, we'll be using the testing of the weights. We'll set them on top, and so then I'm going to make this choice or make this optional for you guys here in Enid. We can either test it next Friday here in Enid, or you can come over to Tonkawa on the 21st and test it over in Tonkawa. So if you wanted to come at 2 o'clock like you guys did for SolidWorks this last Wednesday, you can go over there and I'll test it on Wednesday over in Tonkawa. So it's up to you. I just need to know ahead of time because it looks like I have to bring weights over here if we're going to do it over here. And 1 report per team, and the report will be due February 26th at 5 p.m. So February 26th at 5 p.m., which is a Wednesday. No, February 26th is a Monday. Yeah, Monday at 5 p.m. It's like, remember when you get to have 3 centimeters for support on either side of the table. Yeah, it's got to span 40 centimeters, but you can have a base of 46 centimeters. Yeah, got to have something to hold it onto the table.
We did fine.
Let's see, Ben, yours had the highest at 13 kilograms, or somebody had the highest at 13 kilograms. Yeah, Mike had 13 kilograms on the balsa truss. So, all right, so that's that project. That's the bridge project. I'm going to go ahead, just for time management, because we are in the 4th week of the semester, and I want to give you guys plenty of time for your cardboard chair projects. I'm going ahead and assigning the failure analysis project. And the failure analysis project is this, and everybody's going to do, because I have a small group, everybody's going to do an individual presentation. So this is going to be an individual project. So this is a failure analysis. I've picked a variety of engineering failures. And the idea behind this is that you will talk about why the failure occurred, why is it significant, and what was learned from it. Some of these are significant in that they instituted things like inspection protocols. Some of these are important because they instituted some of the code of ethics for engineers. So some of these are very important from that perspective. So I have assigned each one of you a failure, and the failures are as listed. So Randy's got the Great Molasses Flood of 1919 that happened in Boston. Jonathan, you've got the KXTX radio tower in Cedar Hill, Texas. Armando's got the 1907 Quebec bridge failure, and that's actually 2 failures. Michael, I'm giving you the I-35 2007 bridge collapse, and that's the one that's up in Minnesota. Lansington, you've got the 1928 St. Francis Dam collapse. Zach's going to have the Big Blue Crane. That's the one that collapsed when they were building the Milwaukee Brewers Stadium. So that of course, will be there. Ben, you get the newest one. It's the Hubert Humphrey Metrodome roof collapse. So you get the new one. Jordan's going to have the 2006 Boston Scaffold collapse. Ali's going to do the 1940 Tacoma Narrows Bridge collapse. Jasim's got the Hartford Civic Center collapse, and Marty's got the Hyatt Regency collapse in Kansas City. All of these are really good collapses. We're going to do them in statics class, because that way I've got audiences, because you are going to be graded by your peer groups in terms of how the presentations are done. And so you've got a variety of ways of doing the presentation. It can be a PowerPoint. It can be, you can go ahead and record your presentation ahead of time, and we can run the video. That is up to you. But you will be graded by your peers for that, and we will be doing it during the week of March the 12th. So March 12th and 14th will be the days that are set aside to do these presentations. That way I know I've got the ITV rooms, I've got everything so everybody can be in class. That way I've got it accounted for. And March 16th, which is the day before spring break, I'm not going to be here, and therefore there will be no class. So the March 16th, but that's why we're going to do it that week, and that gets us ahead of the game for a variety of things. So that's the failure analysis report. And there's the rubric for grading the presentation. Everybody's going to grade everybody's presentations. So I will make sure that you guys over here have plenty of sheets for grading or for reviewing presentations, and we will do the presentations back and forth. But so that's where we are in mechanics. And then probably the week of that, or right before that first week in March, I'll go ahead and assign the cardboard furniture project, so that it's assigned and you guys know exactly what's going on for that last part. So that's where we are in that, for that particular aspect. All right, so you guys got questions about the projects that are up? Okie dokie. So now what I'm going to do is I'm going to work through the test so that everybody can have so this video today, for those that aren't here, will have my solutions to the test, and that way you've got those. So let me get the document cam going.
I noticed you didn't assign that library that didn't have the weight of the books accounted for.
The what? The way? Oh no, there's a bunch of them. I can assign it. Actually, one of the ones I wanted to assign, but I just didn't, is the Mecca or the Mecca crane collapse that just happened in 2015. There's a bunch. I picked these for a variety of reasons. These I have a bunch of reasons why I pick which ones I pick. All right, so we're gonna and then just to remind everybody, I did put a lengthy description for the reports on the expectations for the reports so that you have that. All right, so here is the first question, okay? Let's see if I can get it in here. I know a couple of these, I didn't give you guys enough space, but you've got backs of papers to do it. So basically for this one, all you had to do was add vectors A, B, and C. And this gives you, if we do that, you get 13.6i plus 8.5j minus 1.4k. I think most people got that far. So most people got that, at least that portion of the problem. And I think I only had one person that made an arithmetic error along the way. Then you get to you needed to have calculated the magnitude. That was just the square root of 13.6 squared plus 8.5 squared plus 1.4 squared. And that gives you 16.1. Even though I didn't ask for the magnitude, you needed the magnitude in order to calculate the angles. The angle calculations relate back to the cosine, so the angle for Z is going to be the cosine of the inverse cosine of the RZ over R. The angle for Y is going to be the inverse cosine of RX or RY over R. And then the angle for X is just the arc cosine of Rx over R. This gives you, RZ ends up to be about 95 degrees. This one ends up to be about 58.1 degrees. And this one ends up to be about 32.4 degrees. So I think the common mistake was that everybody used tangent, and the way to really do these three-dimensional ones is the easiest way is to do it with cosine rather than the tangent. This one, you just had to write down the vector. R is going to be in the x direction. It's this side right here, so it's 25 meters in the I. In the y direction, it's 110 meters. And in the z direction, it was 65 meters. Just a second. So it raises up. I think just about almost everybody got this one. The next one, there were a couple of ways to do the problem, and you could do it a couple of different ways. I chose to do it the old-fashioned way. I chose to name this vector force 1. I chose to name that vector force 2. So force 1 was equal to 190 cosine of 30 degrees in the I direction plus 190 sine 30 degrees in the J direction, which if you calculate it out, it gets 164.5 in the I direction, 95 in the J direction. You do the same thing for force 2, and that gives you 84.85 in the I direction minus 84.85 in the J direction, and the resultant force was equal to 249 in the I plus 10, 2 in the J. And I didn't intend for you to go ahead and calculate the magnitude and direction. I just wanted the vector. That's okay. You did extra. It's okay. All right. This one. This one's a fun one. Okay? This one's a fun one. I gave you two vectors, and I asked you to calculate the magnitude of P with the given angle. Well, this isn't a good question. This isn't a good question because I gave you the angle. If I give you the angle, it doesn't work. I can't really be in static equilibrium in that case. So I gave credit for a variety of different things in that one. And let me show you what I mean by it can't work. So I'm going to just put up the solution here. So this is the solution. If I do this, I'm looking for P, so I need to know what force 1 is. So that's the 900 cosine of 40. So I get the minus 690I, the positive 578J. Do that for force 2. And then P would have to be this. So that's my P vector. If I'm in static equilibrium, I have to know both the angle and P. So, but I gave you the angle. So if I do the angle, this is what P, and solve for Px, that's what I get for the value of P. If I solve for Py, that's what I get for the value of P. Those two numbers aren't the same, so this obviously isn't in static equilibrium. So, because I was trying to make the problem easy and gave you the actual angle, or gave you an angle, I actually made the problem harder because it turns out that it's not in static equilibrium. So I gave credit if you said, I can't do this problem, actually said you couldn't do the problem. I gave credit if you got the 62.4 or you got the 24.8. What I didn't give credit for is if you did the forced triangle, because the forced triangle should have shown you that it wasn't going to work. So that's, if you did the forced triangle to come up with a value and didn't say, hey, this doesn't work, you only got partial credit. So that's where that problem came from, but it definitely was not the best question. I have a couple more of it's not the best question on this one. So let's do the next one. The next one is you're given a resultant force, or you're given a force AB, you're given a resultant force, and you're asked to solve for the other force. That's what you're asked to do. You're asked to solve for the other force. So the way I did it was this. The way I did it is I got my force resultant is equal to 8.8 newtons plus 50, and that's in the I direction, 50 newtons in the J direction. And I did force, so that's my resultant force, and I did force AB is 60 newtons in the I direction plus 30 newtons in the J direction. The force I want to find is going to be Fx plus Fy. And I'm going to do the resultant force. I'm going to do the resultant force here. So if I look at that, F is going to have to be, I'm going to have to subtract something to get 8.9. This gives me my F2 is going to be 51.2. It's negative. And then my 50 minus 30 gives me 20. And that gives me that one there. I'm going to need, in order to, because one of the things I want to do is draw the forced triangle and calculate all the angles. I'm going to need the magnitudes to do that. So if I do the magnitude of this one, that's the square root of 8.8 squared plus 50 squared, and that equals 50.8. The magnitude of this one is the square root of 60 squared plus 50 or 30 squared, gives me 67.1. And then F2, now that I figured that one out, the magnitude, that gave me a magnitude of about 55. So I have the magnitudes. So what I did next to draw my force triangle is this. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, my force AB was, this is my force AB was 60, 30. So I'm over here 60, 30. So here's my force AB. Then my force, my resultant force was about 10, and it's 50 up. So there's 1, 2, 3, 4, 5. So it would have been about here. So here's my force triangle that I'm looking for. So there's my force triangle. So what I did was this. I used the tangent of the angle was going to equal 50 divided by 8.8. And when I do that, I get an angle of about 80 degrees. That's this angle. Then I did the same thing for this angle, and that's going to be the tangent of 30 divided by 60, which gives me an angle of about 26.6, which gives me this angle becomes 80 minus 26.6. And when I do that, that angle worked out to be 53.4. I now have the magnitude of that. That side, the magnitude was 50.8. The magnitude of this side was 55. And the magnitude of that side was 67. So now I can do FAB over this angle, which is alpha, is equal to F2 over the sine of the 53.4 degrees. And that gives me alpha ends up being 78 degrees. And then I get 180 minus 53.4 minus 78 degrees, or 78.4, which gives me my final one of being 48.2 degrees. So I calculate all the angles. Okay, so then we got this problem. We're given the dimensions and we're given the tensions, and we want to calculate the resultant force. So I'm going to go ahead and pull this one up because it's nice. It fits on there pretty well. So basically, my A was minus 4 plus 4 plus 12. So A, I set this to be on the minus side, so it's minus 4 meters, plus 4 meters, because this is the positive side of the y, and then we're plus 12 meters. So minus 4 plus 4 plus 12. Vector B, I'm still on the minus side of the x, minus 4. I'm on the minus side of the y, minus 6. I'm on the plus side of my 12, so I get minus 4, minus 6, plus 12. Then for C, it's actually on the x-axis, so I get my 5 plus 5, but that means it's no y is equal to 0, because I'm not straying from the x-axis. And then I'm 12, so there's my third vector is right here. 5, and 12. I'm going to need the magnitudes because I want to calculate my unit vectors. So this one is 13.3, this one is 14, this one is 13. When I take my 4 divided by my 13.3, I get my 0.302. This is negative, positive, positive. I do the same thing here, except now I take my minus 4 divided by 14, my minus 6 divided by 14, and my 12 divided by 14, and I get that unit vector. And then I get the final unit vector here. So now I can do a calculation that looks like this. I take TOA, which is I said it's 368 newtons. So I plug it in, and that gives me my tension in TOA. So that gives me that vector. Then I do the same for TOB, and I do the same for TOY. You add up these, you get 0. You add up these, you get 0. And you add up those, and you get 1,000. So the hardest part about this particular problem is really getting those 3 initial direction vectors. Okay. The next one. This is another one that I intended for it to be easy, and it may have been a little more complicated. I intended it for it to be easy. The way I intended for it to go is this. Basically, you've been given the magnitude of R, and you've been given 2 of the angles. So you can do this. Magnitude of R is equal to the square root of Rx squared plus Ry squared plus Rz squared. The only part you really don't know is Rz. And so you could have done the cosine of, the arc cosine of Rz over R is equal to the angle. And when you do that, you're going to end up with 75.5 degrees. And the way so if you know what Rx is cosine of the one angle. Ry is cosine of the other angle. But you can do that, and you find that Rz, when you know that this is 200, and you know what these are based on your 2 angles, you find that Rz ends up being 10,000. And that becomes 10,000 over 4,000. This becomes the arc cosine of 0.25. However, there's a couple of things that you could do, since this is around the z-axis. I really kind of didn't give you a whole, all the information. I would have accepted multiple angle values, but, or you could have also done it like this. Cosine of alpha squared plus cosine of beta squared plus cosine of gamma squared has got to equal 1. That's going to give you a different angle as well, but I gave full credit for that. So there's a couple of ways of doing it. If you attempted the problem, you got 5 points. Because there's, like I said, there's a couple of ways of doing it, a couple of different strategies, and I gave you credit for strategy. This one, you were trying to find the unit vector. The unit vector is just going to be R over the magnitude of R. R happens to be 3I plus 2J. Magnitude of R is going to work out to be the square root of 13. The unit vector then works out to be 0.83I plus 0.55J. So that one wasn't intended to be hard at all. The last two were intended to be pretty straightforward. You were just asked to find the weight of the truck. If you tried to use the forced triangle on this one, it doesn't quite work because this tension and this string, in order to be in static equilibrium, isn't exactly in just the y direction, but you still can find the weight of the truck. So basically you do the tension in the y direction, or T1, or T1 is going to be, let's see, T1X is going to be my 1,500 pounds. And it's going to be the sine, this is supposed to be y, sorry, 1,500 pounds supposed to be the sine of 60 degrees. T2y is going to be the 2,200 pounds sine of 45 degrees. When you get those numbers and you add them together, because that's what has to balance in the y direction, you work it out to be 28.546 or something, so it's about 28.55 pounds. This one, you're given those. So the way to do this is you start out with a squared is equal to b squared plus c squared minus 2bc cosine of an angle. I chose to do this, if I resolve it for cosine of the angle, I chose to do this for 24 squared minus 16 squared minus 20 squared divided by minus 2 times my 16 times my 20 gives me, that value ended up being 0.128. That gave me that angle to be 83 degrees. That gives me 83 degrees. That is this angle here. Then I did 20 over the sine of alpha is equal to 24 over the sine of 83 degrees. That gave me alpha being 56 degrees. That's this one. And then I just used 180 minus 56 and 83, and that gave me 41 degrees. So I've got them all graded except for you guys, because I haven't actually seen Enid's yet, because they came over in the courier, so they didn't get there until late yesterday. So I haven't actually graded you guys' yet, but I graded everybody else's. So they're all graded, and I will get them back to you guys. I'll get them back to you guys on Monday, and then Monday we start dealing with moments and start working on moments and things like that. So I should get this uploaded. You guys have the statics problem or the engineering mechanics problem, 16 pieces of standard copy paper to build a bridge. And we'll see you guys on Monday. I did it in here. Where is